The story of the invention of the commercial airplane. The invention of commercial airplanes has revolutionized the way we travel and do business. But how did this amazing invention come to be? Let's take a journey through time to discover the story of commercial airplane invention. It all started with the Wright brothers, Orville and Wilbur, who made history on December 17, 1903, when they successfully flew the first powered airplane. This achievement marked the beginning of the aviation industry, and it wasn't long before people started to realize the potential for commercial air travel. The first commercial airline, St. Petersburg Tampa Airboat Line, was established in 1914 in Florida. This airline operated a small seaplane that could carry just one passenger at a time. However, it was the first step towards what would become a multi-billion-dollar industry. Over the next few decades, airplane technology continued to develop, and commercial airlines started to become more common. In the 1930s, the first airliners were introduced, which were capable of carrying more passengers and traveling longer distances. This was a significant step forward in commercial aviation, and it paved the way for the modern airline industry. One of the most significant developments in commercial aviation was the introduction of the Boeing 707 in 1958. This airplane was the first commercial jetliner, and it could travel at speeds of up to 600 miles per hour. The Boeing 707 was a game-changer in the airline industry, as it allowed airlines to fly longer distances in a shorter amount of time. Another significant development in commercial aviation was the introduction of the Airbus A380 in 2005. This airplane was the largest commercial passenger plane ever built and could carry up to 853 passengers. The A380 was a technological marvel, and it allowed airlines to transport more passengers than ever before. Today, commercial aviation is an essential part of our lives. It has connected people from all over the world, allowing us to travel to new places and experience new cultures. It has also played a significant role in the global economy, as it has made it easier for businesses to operate across borders. During times of natural disasters, commercial airlines have transported supplies and aid workers to affected areas. They have also helped in the evacuation of people from dangerous situations. In times of war, commercial airlines have played a crucial role in transporting troops, equipment, and supplies to and from the front lines. Furthermore, commercial airlines have made it possible for people to experience the world and connect with others in ways that were once unimaginable. They have opened up new opportunities for tourism, education, and cultural exchange. Additionally, they have facilitated the movement of people and goods, contributing to the growth of economies worldwide. In recent years, there have been growing concerns about the environmental impact of commercial aviation. Airplanes contribute to greenhouse gas emissions and air pollution, and the industry has been working to develop more sustainable solutions. Aircraft manufacturers are exploring new technologies, such as electric and hydrogen-powered planes, to reduce emissions and minimize their impact on the environment. As the aviation industry continues to evolve, there are several emerging trends and technologies that are set to shape its future. One of the most significant trends is the rise of low-cost carriers, which offer affordable air travel to a wider range of people. This has led to increased competition in the industry, forcing established airlines to adapt and evolve to stay relevant. Another trend is the use of digital technology to enhance the passenger experience. From online check-ins to in-flight entertainment, technology is transforming the way we fly. Airlines are also exploring the use of virtual and augmented reality to create immersive experiences for passengers. The aviation industry is also embracing artificial intelligence and data analytics to improve operations and enhance safety. Airlines are using predictive analytics to anticipate maintenance needs and prevent downtime, while AI-powered chatbots are being used to improve customer service and streamline processes. In terms of aircraft technology, there is a growing interest in supersonic flight, which could significantly reduce travel times. Companies such as Boom Supersonic and Ariane are developing supersonic planes that could fly at speeds of up to Mach 2.2. There is also a growing focus on sustainable aviation fuels, SAF, which are produced from renewable sources such as algae and waste oils. SAF has the potential to significantly reduce greenhouse gas emissions, making air travel more environmentally friendly. Another trend that is shaping the future of commercial aviation is the increasing use of automation and robotics. Airlines are exploring the use of autonomous ground vehicles to transport baggage and cargo, while robotics is being used to automate aircraft maintenance and inspections. Drones are also being used to inspect runways and monitor airport operations. In addition, the aviation industry is embracing the concept of smart airports, which leverage technology to create a more efficient and seamless passenger experience. Smart airports use data analytics to optimize airport operations, from check-in and security to baggage handling and boarding. Furthermore, the COVID-19 pandemic has had a significant impact on the aviation industry, prompting airlines to adapt and innovate to ensure passenger safety. This has included the use of enhanced cleaning protocols, mandatory mask wearing, and the implementation of contactless technologies. One area of innovation that has emerged as a result of the pandemic is the development of health passports, which allow passengers to securely share their health information with airlines and border control authorities. These passports could play a critical role in enabling safe travel in the post-pandemic world. Finally, the aviation industry is also exploring the concept of flying cars and urban air mobility. Several companies are developing vertical takeoff and landing (VTOL) aircraft that could be used for short-distance urban transport. While this technology is still in the early stages of development, it has the potential to revolutionize urban transportation and reduce traffic congestion. Another important trend that is shaping the future of commercial aviation is the increasing focus on sustainability and reducing the environmental impact of air travel. In addition to exploring sustainable aviation fuels, airlines and aircraft manufacturers are also investing in research and development of electric and hybrid electric aircraft. Electric aircraft have the potential to significantly reduce greenhouse gas emissions, noise pollution, and fuel consumption. Several companies are already working on developing electric aircraft for commercial use, including Eviation, which is developing the Alice electric plane that could carry up to 9 passengers over distances of up to 620 miles. Inside the fighter. Fighter jets are some of the most advanced and sophisticated machines on the planet. These aircraft are designed for one purpose: to dominate the skies and engage in air-to-air combat. Inside a fighter jet, there are a vast array of systems and technologies that enable the pilot to fly at incredible speeds, maneuver with precision, and engage the enemy with lethal force. The cockpit of a fighter jet is a marvel of engineering. The pilot's seat is designed to keep the pilot comfortable and secure during high-G maneuvers. The controls in the cockpit are ergonomically designed to allow the pilot to manipulate the aircraft with ease. The cockpit is also equipped with advanced avionics systems that provide the pilot with real-time information about the aircraft's systems, flight conditions, and the environment around them. One of the most important systems in a fighter jet is the engine. Fighter jets are powered by some of the most powerful engines in the world. These engines are capable of producing thrust in excess of 50,000 pounds, allowing the aircraft to fly at speeds in excess of Mach 2. The engines also provide the aircraft with the ability to climb rapidly, enabling the pilot to gain an altitude advantage over the enemy. Fighter jets are also equipped with advanced sensors and weapons systems. These systems allow the pilot to detect and engage targets at extreme ranges. The sensors are capable of detecting enemy aircraft, ground targets, and even missiles. The weapon systems on a fighter jet are designed to be lethal and precise. They include machine guns, missiles, and bombs, and are capable of destroying enemy targets with incredible accuracy. Another critical system in a fighter jet is the life support system. Fighter jets operate at altitudes where the air is too thin to breathe. The life support system provides the pilot with the oxygen and pressurization they need to survive. This system is essential for the pilot to operate the aircraft effectively and safely. In addition to the systems mentioned earlier, fighter jets also have advanced defensive systems. These systems are designed to protect the aircraft and the pilot from enemy attacks. One critical component of the defensive system is the electronic countermeasures (ECM) system. The ECM system jams enemy radar and communication systems, making it difficult for the enemy to detect and target the aircraft. Another important defensive system is the chaff and flare dispensers. These systems release small pieces of metal or plastic called chaff and flares, respectively. The chaff creates a cloud of reflective material that confuses enemy radar, while the flares distract enemy. Heat-seeking missiles by creating a heat signature that mimics the aircraft's engine exhaust. Fighter jets also have advanced communication systems that allow the pilot to communicate with other aircraft and ground control. These systems are essential for coordinating attacks and receiving updated information about the battlefield. Finally, fighter jets are also equipped with advanced navigation systems. These systems include GPS, inertial navigation, and terrain-following radar. These systems enable the pilot to fly the aircraft with precision, even in adverse weather conditions or low visibility. The design of fighter jets has evolved significantly over the years as technology has advanced. Modern fighter jets are designed to be stealthy, making them difficult to detect by enemy radar. They are also designed to be agile, allowing them to maneuver quickly and evade enemy attacks. One of the most significant advances in fighter jet technology is the use of fly-by-wire systems. Fly-by-wire systems replace traditional mechanical controls with electronic controls, making the aircraft more responsive and easier to fly. These systems also provide the pilot with more precise control over the aircraft's movements, enabling them to perform complex maneuvers with ease. Another important advance in fighter jet technology is the use of advanced materials in the aircraft's construction. These materials, such as carbon fiber composites, are lightweight and strong, allowing the aircraft to be more maneuverable and faster. The use of advanced materials also reduces the aircraft's radar signature, making it more difficult for the enemy to detect. Fighter jets are also equipped with advanced sensors that provide the pilot with real-time information about the aircraft's systems and the environment around them. These sensors include radar, electro-optical/infrared sensors, and laser rangefinders. They allow the pilot to detect and track enemy aircraft and ground targets, even in adverse weather conditions. Finally, fighter jets are equipped with advanced training systems that allow pilots to hone their skills in a simulated environment. These systems use virtual reality technology to simulate realistic combat scenarios, allowing pilots to practice their tactics and maneuvers in a safe and controlled environment. One of the key challenges in designing fighter jets is balancing the competing demands of speed, maneuverability, and range. Fighter jets must be able to fly at high speeds to engage enemy aircraft, but they must also be agile enough to evade enemy attacks. Additionally, fighter jets must have sufficient range to operate over long distances, allowing them to reach the battlefield and engage the enemy. To achieve these objectives, fighter jets are equipped with advanced aerodynamic designs. These designs are optimized for speed and maneuverability, allowing the aircraft to fly at high speeds and perform complex maneuvers. The wings of fighter jets are typically swept back, which reduces drag and increases the aircraft's speed. Additionally, fighter jets often have canards, which are small wing-like structures located near the front of the aircraft. Canards provide additional lift and maneuverability, allowing the aircraft to perform tight turns and other complex maneuvers. Fighter jets are also equipped with advanced weapon systems that allow them to engage enemy targets at long ranges. These weapon systems include air-to-air missiles, air-to-surface missiles, and bombs. Air-to-air missiles are designed to engage enemy aircraft, while air-to-surface missiles and bombs are designed to engage ground targets. Finally, fighter jets are equipped with advanced maintenance and diagnostic systems. These systems allow ground crews to monitor the aircraft's systems and diagnose any issues that arise. How gene analyzers work. Genetic analysis is the study of DNA and genetic information to identify and understand genetic variations and mutations that can affect an organism's traits, health, and susceptibility to disease. There are several types of genetic analysis methods that are commonly used in research and clinical settings, each with its own advantages and limitations. The first type of genetic analysis is DNA sequencing, which is the process of determining the order of nucleotides in a DNA molecule. DNA sequencing can provide a comprehensive view of an individual's genetic makeup, including both coding and non-coding regions of the genome. This method is useful for identifying genetic mutations that cause disease and for studying genetic variation across populations. Another type of genetic analysis is genotyping, which is the process of identifying specific genetic variations in an individual's DNA. This method is often used to study genetic associations with disease and to identify genetic markers that can be used for diagnostic and prognostic purposes. Genotyping can be performed using various techniques, including polymerase chain reaction, PCR, and microarray analysis. Gene expression analysis is another type of genetic analysis that measures the activity of genes in cells or tissues. This method can provide insight into the underlying mechanisms of disease and can identify potential drug targets. Gene expression analysis can be performed using techniques such as RNA sequencing and microarray analysis. Epigenetic analysis is a type of genetic analysis that measures modifications to the DNA molecule that affect gene expression without changing the underlying DNA sequence. Epigenetic modifications can be influenced by environmental factors and can have a significant impact on an individual's health and susceptibility to disease. Epigenetic analysis can be performed using techniques such as bisulfite sequencing and chromatin immunoprecipitation (CHIP) sequencing. Metagenomic analysis is a type of genetic analysis that examines the genetic material present in complex microbial communities, such as those found in the human gut. This method can provide insight into the diversity and function of microbial communities and can identify potential targets for intervention in diseases such as inflammatory bowel disease and obesity. Another type of genetic analysis is comparative genomics, which is the study of the similarities and differences in the genetic makeup of different species. This method can provide insight into the evolution of species and the genetic basis of traits that are unique to certain species. Comparative genomics can be used to identify genes that are important for development, disease resistance, and other traits. Functional genomics is a type of genetic analysis that studies the function of genes and their interactions with other genes and proteins. This method can provide insight into the underlying mechanisms of disease and can identify potential drug targets. Functional genomics can be performed using techniques such as gene editing, RNA interference, and CRISPR/Cas9. Pharmacogenomics is a type of genetic analysis that studies how an individual's genetic makeup affects their response to drugs. This method can provide insight into which drugs are most likely to be effective for an individual and can help to minimize the risk of adverse drug reactions. Pharmacogenomics can be used to develop personalized treatment plans for patients with a variety of conditions, including cancer, cardiovascular disease, and psychiatric disorders. Finally, population genetics is a type of genetic analysis that studies the genetic variation within and between populations. This method can provide insight into the genetic basis of complex traits, such as height and intelligence, and can identify genetic risk factors for common diseases. Population genetics can be used to develop personalized prevention and treatment strategies for individuals based on their genetic risk profiles. One more type of genetic analysis is transcriptomics, which is the study of the entire set of RNA molecules produced by a cell or tissue. This method provides insight into the expression levels of genes and the regulation of gene expression. Transcriptomics can be used to identify new drug targets and to develop personalized treatment plans for patients with a variety of conditions, including cancer and autoimmune diseases. Proteomics is another type of genetic analysis that studies the entire set of proteins produced by a cell, tissue, or organism. This method provides insight into the functional properties of proteins and their interactions with other proteins and molecules. Proteomics can be used to identify new drug targets and to develop personalized treatment plans for patients with a variety of conditions, including cancer and neurological disorders. Metabolomics is a type of genetic analysis that studies the entire set of small molecules, or metabolites, produced by a cell, tissue, or organism. This method provides insight into the metabolic pathways and processes that are active in a particular cell or tissue. Metabolomics can be used to identify biomarkers for disease and to develop personalized treatment plans for patients with a variety of conditions, including diabetes and cardiovascular disease. Finally, systems biology is a type of genetic analysis that combines multiple types of genetic and molecular data to build a comprehensive model of biological systems. This method provides insight into the complex interactions between genes, proteins, metabolites, and other molecules that are involved in cellular and organismal function. Systems biology can be used to identify new drug targets and to develop personalized treatment plans for patients with a variety of conditions, including cancer and infectious diseases. Another type of genetic analysis is epitranscriptomics, which is the study of chemical modifications to RNA molecules. This method provides insight into the regulation of gene expression and the functional properties of RNA molecules. Epitranscriptomics can be used to identify new drug targets and to develop personalized treatment plans for patients with a variety of conditions, including cancer and neurological disorders. Single-cell genomics is a type of genetic analysis that studies the genetic and molecular properties of individual cells. This method provides insight into the heterogeneity of cell populations and the role of individual cells in disease processes. Single-cell genomics can be used to identify new drug targets and to develop personalized treatment plans for patients with a variety of conditions, including cancer and autoimmune diseases. Genetic analysis is a rapidly growing field that has revolutionized our understanding of biology and medicine. With the advent of modern genetic technologies, scientists are now able to study the genetic makeup of organisms at an unprecedented level of detail, providing valuable insights into the inner workings of cells and the basis of inherited diseases. In this article, we will explore the different types of genetic analysis and how they are used to understand the operation of genes. The first type of genetic analysis is called genotyping, which involves identifying specific genetic variations or polymorphisms within an individual's DNA. This can be done using a variety of techniques, such as microarray analysis or DNA sequencing. Genotyping is commonly used in medical research to study the genetic basis of diseases, as well as in forensic investigations to identify suspects. Another type of genetic analysis is gene expression analysis, which involves measuring the activity of genes within a cell or tissue. This can be done using techniques such as microarray analysis or RNA sequencing. Gene expression analysis is useful in studying the regulation of gene activity and in identifying genes that are involved in particular biological processes. A third type of genetic analysis is epigenetic analysis, which involves studying modifications to the DNA molecule that do not involve changes to the DNA sequence itself. These modifications can include the addition or removal of chemical groups that can affect gene expression. Epigenetic analysis is useful in understanding how environmental factors can influence gene activity and in identifying potential targets for drug development. Discover the process of making vaccines. Vaccines have been crucial in the fight against many infectious diseases. They work by stimulating the body's immune system to recognize and fight off specific pathogens. The process of developing vaccines can be complex and time-consuming, but it is essential for protecting public health. There are several types of vaccines, including live attenuated, inactivated, subunit, conjugate, DNA, and mRNA vaccines. Each type of vaccine targets different types of pathogens and uses different methods to stimulate the immune system. Live attenuated vaccines are made from weakened forms of the pathogen. These vaccines are effective because they closely mimic the natural infection, stimulating a strong immune response. However, they can be dangerous for people with weakened immune systems, and there is a risk that the weakened pathogen could revert to its virulent form. Inactivated vaccines are made from killed pathogens. Because the pathogen is dead, there is no risk of causing disease. However, these vaccines may not be as effective as live attenuated vaccines, and multiple doses may be required to build up immunity. Subunit vaccines are made from fragments of the pathogen, such as proteins or sugars. These vaccines are safe because they do not contain the whole pathogen, but they may not be as effective as live attenuated vaccines. Conjugate vaccines are used for bacteria that have a protective outer coat. The vaccine combines the outer coat with a harmless protein to stimulate the immune system. This type of vaccine is particularly effective for young children, who may not have a strong immune response to the outer coat alone. DNA vaccines use a small piece of the pathogen's DNA to stimulate the immune system. This type of vaccine is still in the experimental stage, but it has the potential to be effective against a wide range of pathogens. mRNA vaccines are a new type of vaccine that have been developed recently. They work by introducing a small piece of genetic material from the pathogen into the body, which stimulates the immune system to produce a response. mRNA vaccines have been very effective against COVID-19 and are being studied for use against other diseases. The process of developing a vaccine can take many years and involves several stages. First, researchers identify the pathogen and study its structure and behavior. Then, they develop a vaccine candidate and test it in animals to ensure that it is safe and effective. If the animal studies are successful, the vaccine candidate is tested in humans in clinical trials. These trials involve several phases and can take several years to complete. If the vaccine is found to be safe and effective, it can be approved for use by regulatory agencies. In summary, vaccines are a critical tool in the fight against infectious diseases. There are several types of vaccines, each with its strengths and weaknesses. The process of developing a vaccine can be complex and time-consuming, but it is essential for protecting public health. Once a vaccine has been approved, it must be manufactured on a large scale to ensure that it is available to those who need it. The manufacturing process can vary depending on the type of vaccine, but it typically involves growing the pathogen and then processing it to create the vaccine. For live attenuated vaccines, the pathogen is grown under specific conditions that weaken it. The weakened pathogen is then processed to create the vaccine. Inactivated vaccines are made by growing the pathogen and then killing it using heat or chemicals. The dead pathogen is then processed to create the vaccine. Subunit vaccines are made by growing the pathogen and then isolating the specific fragment that will be used in the vaccine. The fragment is purified and then processed to create the vaccine. Conjugate vaccines are made by combining the outer coat of the bacteria with a harmless protein. The resulting conjugate is then processed to create the vaccine. DNA vaccines are made by synthesizing a small piece of the pathogen's DNA and then introducing it into a bacterial or mammalian cell. The cell then produces the antigen, which is purified and used as the vaccine. mRNA vaccines are made by synthesizing a piece of mRNA that codes for the antigen. The mRNA is then packaged into a lipid nanoparticle and administered as the vaccine. Once the vaccine has been manufactured, it must be distributed and administered to the population. This can be a complex process, particularly in areas with limited healthcare infrastructure. Vaccines must be stored and transported at specific temperatures to ensure their effectiveness, and healthcare workers must be trained to administer them safely. In summary, the process of developing and manufacturing vaccines is complex and time-consuming, but it is essential for protecting public health. Once a vaccine has been approved, it must be manufactured on a large scale and distributed to the population. Healthcare workers play a critical role in administering vaccines safely and effectively. In addition to the challenges of developing and manufacturing vaccines, there are also challenges associated with ensuring that they are accessible to everyone who needs them. This is particularly true in low and middle income countries, where healthcare infrastructure may be limited and vaccine costs may be prohibitive. To address these challenges, international organizations such as the World Health Organization, WHO, and Gavi, the Vaccine Alliance, work to ensure that vaccines are available and affordable in these countries. This may involve negotiating with pharmaceutical companies to lower vaccine prices, providing funding for vaccine programs, and supporting healthcare infrastructure development. Another challenge associated with vaccines is vaccine hesitancy, which is the reluctance or refusal to vaccinate despite the availability of vaccines. Vaccine hesitancy can be driven by a variety of factors, including misinformation, mistrust of healthcare providers, and concerns about vaccine safety. Addressing vaccine hesitancy requires a multifaceted approach that includes education, community engagement, and addressing underlying social and cultural factors. Despite these challenges, vaccines have been crucial in the fight against many infectious diseases. Vaccines have helped to eradicate smallpox, reduce the incidence of polio, and protect against diseases such as measles, mumps, and rubella. Mechanism of action: cancer treatment drugs. Cancer is a complex and multifaceted disease that can be difficult to treat. There are many different types of cancer, each with its unique characteristics, and treatment often requires a combination of therapies. One of the most common treatments for cancer is chemotherapy, which uses drugs to kill cancer cells. Chemotherapy drugs work by targeting rapidly dividing cells, which includes cancer cells. However, they can also damage healthy cells that divide rapidly, such as those in the bone marrow, digestive tract, and hair follicles. This can lead to side effects such as fatigue, nausea, and hair loss. Another type of cancer treatment is targeted therapy, which uses drugs that specifically target the proteins or molecules that are involved in the growth and spread of cancer cells. Targeted therapy is often less toxic than chemotherapy and can have fewer side effects. However, it is only effective for cancers that have specific molecular targets. Immunotherapy is another type of cancer treatment that works by stimulating the immune system to recognize and attack cancer cells. This can be done by using drugs that block the proteins that inhibit the immune response or by using genetically engineered immune cells that can target cancer cells. Hormone therapy is a type of cancer treatment that is used to treat cancers that are hormone responsive, such as breast and prostate cancer. Hormone therapy works by blocking the production or action of hormones that promote cancer growth. In addition to these treatments, there are also several types of supportive therapies that can help to manage the side effects of cancer treatment. These include anti-nausea medications, pain management, and psychological support. The choice of cancer treatment depends on several factors, including the type and stage of cancer, the patient's overall health, and the potential side effects of treatment. Treatment plans are often developed by a multidisciplinary team that includes oncologists, nurses, and other healthcare professionals. Chemotherapy, targeted therapy, immunotherapy, and hormone therapy all work in different ways to treat cancer, but they share the common goal of destroying or slowing the growth of cancer cells. These treatments can be used alone or in combination with each other to achieve the best possible outcome for the patient. Chemotherapy drugs are often given in cycles, with periods of treatment followed by periods of rest to allow the body to recover. The specific drugs and dosages used depend on the type and stage of cancer and the patient's overall health. Chemotherapy can be given orally, intravenously, or through injection. Targeted therapy drugs are often given orally and can be taken at home. These drugs target specific molecules or proteins that are involved in cancer growth, and can have fewer side effects than chemotherapy. Immunotherapy drugs are often given intravenously and can cause side effects such as flu-like symptoms, but they can also have long-lasting benefits for some patients. Immunotherapy can be particularly effective for cancers that have spread to other parts of the body. Hormone therapy drugs are often given orally and work by blocking the production or action of hormones that promote cancer growth. Hormone therapy can be particularly effective for hormone-responsive cancers such as breast and prostate cancer. While these treatments can be effective in treating cancer, they can also have side effects that can impact a patient's quality of life. Side effects can include fatigue, nausea, hair loss, and changes in appetite. Supportive therapies such as anti-nausea medications, pain management, and psychological support can help to manage these side effects and improve the patient's overall experience. In addition to the types of cancer treatment mentioned above, there are also emerging therapies that show promise in treating cancer. These therapies include gene therapy, CAR T-cell therapy, and cancer vaccines. Gene therapy involves modifying a patient's genes to treat or prevent disease. In the context of cancer treatment, gene therapy can be used to modify immune cells to better target cancer cells or to repair or replace genes that are defective in cancer cells. CAR T-cell therapy is a type of immunotherapy that involves genetically modifying a patient's T cells to better target cancer cells. CAR T-cell therapy has shown promising results in treating certain types of blood cancers, and research is ongoing to explore its potential in other types of cancer. Cancer vaccines are being developed to help the immune system recognize and attack cancer cells. These vaccines can be used to prevent cancer from developing in individuals who are at high risk or to treat cancer in individuals who have already been diagnosed. Another emerging area of cancer treatment is personalized medicine, which involves tailoring treatment to the specific characteristics of a patient's cancer. This can involve using genetic testing to identify specific mutations that are driving cancer growth and selecting treatments that target these mutations. In addition to these emerging therapies, there are also efforts to improve the delivery of existing therapies. For example, researchers are exploring the use of nanoparticles to deliver chemotherapy drugs directly to cancer cells, which can reduce side effects and increase the effectiveness of treatment. The development of new cancer treatments is a complex and time-consuming process that involves preclinical research, clinical trials, and regulatory approval. Preclinical research involves testing new treatments in laboratory models to determine their safety and efficacy. Promising treatments are then tested in clinical trials, which involve testing the treatment in human patients. Clinical trials are conducted in multiple phases, with each phase designed to answer specific questions about the safety and efficacy of the treatment. Phase I trials involve testing the treatment in a small group of patients to determine the optimal dose and to identify any potential side effects. Phase II trials involve testing the treatment in a larger group of patients to further evaluate its safety and efficacy. Phase III trials are large-scale trials that compare the new treatment to the standard of care to determine its effectiveness. If a treatment is found to be safe and effective, it can be submitted for regulatory approval to be marketed to patients. In addition to the development of new treatments, there are also efforts to improve access to existing treatments. This can involve negotiating lower drug prices, expanding insurance coverage, and improving healthcare infrastructure in underserved areas. Patient advocacy groups also play an important role in cancer treatment research and access. These groups work to raise awareness about the importance of cancer research, advocate for policies that improve cancer care, and provide support for cancer patients and their families. In conclusion, the development of new cancer treatments is a complex and time-consuming process that involves preclinical research, clinical trials, and regulatory approval. Improving access to existing treatments is also an important part of cancer treatment research. Patient advocacy groups play an important role in cancer treatment research and access, and their work is essential for improving cancer care and outcomes. Continued investment in cancer treatment research and access is essential for improving cancer care and outcomes for patients and their families. The field of cancer treatment is constantly evolving, and new discoveries are being made all the time. The process of invention of various types of smart medical devices. The field of healthcare has been revolutionized by the development of smart medical devices. These devices use advanced technology to monitor and treat patients, improve the accuracy of diagnoses, and provide real-time data to healthcare providers. The process of inventing smart medical devices is complex and involves several stages. The first stage is idea generation, where inventors come up with new concepts for devices that can improve healthcare outcomes. This can involve brainstorming, market research, and collaboration with healthcare professionals. Once an idea has been generated, the next stage is prototyping. This involves creating a working model of the device, which can be tested and refined. Prototyping can involve 3D printing, computer-aided design, CAD, and other advanced manufacturing techniques. After the device has been prototyped and refined, it can then move on to clinical trials. Clinical trials involve testing the device in human patients to determine its safety and efficacy. This can involve several phases of testing, with each phase designed to answer specific questions about the device's safety and effectiveness. If a device is found to be safe and effective, it can then move on to regulatory approval. This involves submitting the device to regulatory agencies, such as the Food and Drug Administration, FDA, for approval to be marketed and sold to healthcare providers. Some examples of smart medical devices include wearable sensors that can monitor vital signs. such as heart rate and blood pressure, mobile apps that can track medication adherence and provide behavioral interventions, and smart inhalers that can monitor and improve asthma management. Smart medical devices have the potential to revolutionize healthcare by improving patient outcomes, reducing healthcare costs, and increasing access to care. However, there are also challenges associated with the development and implementation of these devices, such as data privacy concerns and the need for regulatory oversight. Smart medical devices continue to evolve and improve as technology advances. One area of development is the use of artificial intelligence, AI, and machine learning to improve the functionality and accuracy of these devices. AI and machine learning can be used in several ways in smart medical devices. For example, they can be used to analyze large amounts of patient data to identify patterns and make treatment recommendations. They can also be used to improve the accuracy of diagnoses by analyzing medical images or other diagnostic tests. Another area of development is the use of Internet of Things, IoT, technology in smart medical devices. IoT devices can be interconnected and communicate with each other, allowing for real-time monitoring and data analysis. This can improve the accuracy of diagnoses and enable healthcare providers to make more informed treatment decisions. Smart medical devices are also becoming more personalized, with a focus on tailoring treatment to the specific needs of individual patients. This can involve using genetic testing to identify specific mutations that are driving disease and selecting treatments that target these mutations. It can also involve using data from wearable sensors and other devices to monitor patients in real time and adjust treatment plans accordingly. Finally, there is a growing focus on improving the user experience of smart medical devices. This can involve designing devices that are easy to use and intuitive, as well as providing training and support to healthcare providers to ensure that they are able to use these devices effectively. Smart medical devices are also being integrated into telemedicine practices, which allow for remote monitoring and treatment of patients. This is particularly useful for patients who live in remote or underserved areas, as well as for those who have difficulty accessing traditional healthcare services. Telemedicine practices can include virtual consultations, remote monitoring of vital signs, and the use of mobile apps to track symptoms and provide behavioral interventions. Smart medical devices are an essential component of telemedicine practices, as they allow for the collection and transmission of real-time data to healthcare providers. Another area of development is the use of nanotechnology in smart medical devices. Nanotechnology involves the manipulation of materials at the nanoscale level, which can be used to create devices that are smaller and more precise than traditional medical devices. Nanotechnology can also be used to create devices that are biocompatible, meaning that they are less likely to cause adverse reactions in the body. Smart medical devices are also being developed to address specific healthcare challenges. For example, there are devices being developed to improve the management of chronic conditions such as diabetes and heart disease, as well as devices that can improve the accuracy of cancer diagnoses. Smart medical devices are also being developed to address the challenges posed by aging populations and the increasing prevalence of chronic diseases. These devices can help to improve the quality of life for older adults and patients with chronic conditions by allowing them to manage their health more effectively and remain independent for longer. One area of development is the use of smart home technology in healthcare. Smart home devices, such as voice assistants and smart sensors, can be used to monitor and manage the health of older adults and patients with chronic conditions. For example, smart sensors can detect falls or changes in activity levels, while voice assistants can provide medication reminders or answer questions about health conditions. Another area of development is the use of virtual and augmented reality in healthcare. These technologies can be used to provide immersive experiences that can help patients manage pain, anxiety, and other symptoms. For example, virtual reality can be used to create calming environments for patients undergoing medical procedures, or to provide distraction therapy for patients with chronic pain. Smart medical devices are also being developed to address the challenges posed by infectious diseases. For example, there are devices being developed to monitor and diagnose infectious diseases such as COVID-19. These devices can provide real-time data on the spread of disease, allowing healthcare providers to respond more quickly and effectively. Finally, there is a growing recognition of the importance of data privacy and security in smart medical devices. As these devices collect and transmit sensitive patient data, it is essential that appropriate measures are taken to protect this data from unauthorized access or use. In conclusion, smart medical devices continue to evolve and improve as technology advances. Telemedicine practices, nanotechnology, disease-specific devices, and data privacy and security are all areas of active research and development that hold promise for improving healthcare outcomes and promoting patient well-being. Continued investment in the development of these devices is essential for improving healthcare outcomes and promoting patient well-being. Smart medical devices are also being developed to address healthcare disparities and improve access to healthcare for underserved populations. This is particularly important in low and middle income countries, where access to healthcare can be limited due to factors such as cost, location, and infrastructure. One area of development is the use of mobile health (mHealth) technology. mHealth involves the use of mobile devices such as smartphones and tablets to deliver healthcare services and information.